today we are going to be using the reduced row echelon form, which that's just the format where you end up with 1, 0, 0. And this time we're going to add in an extra column. It's going to be our answer column, and it's going to have a number. And then you're going to do the 0, 1, 0, and then it's going to equal a number. And 0, 0, 1, and it's going to equal a number. That's what reduced row echelon form looks like. And instead of a squiggly line, it's often written, if it's done by hand, with a straight up and down line like this. Now we're going to be using it in the calculator, and that yellow line does not show up in your calculator. Just like when we were doing Kramer's rule and we were doing the matrix equation method, you need your x, y, and z all on the same side. So if we look at their problems here, we have z equals 3x plus 3y plus 16 and 2y minus 6z equals negative 18 and y equals negative 2x minus 5z equals 8. So we need to get them all with the same variables, all the variables on the left-hand side. So I'm going to take the green equation first. Z equals 3x plus 3y plus 16. And I realized I didn't give myself enough room to write on the other side. So let me rewrite that. I need to get to where I have everything over here on this side. So that means I need to move these over here. So to move the 3x is positive, so I have to subtract 3x. And subtract 3x over here. The 3y is a plus 3y, so I subtract 3y. Subtract 3y. My 16 I want to remain on the right-hand side, and my z is positive. So I'm going to put a plus sign in front of it. So when I rewrite it, it becomes negative 3x minus 3y plus z equals 16. So that's one of my equations. Then I want to look at the blue equation. I don't have any x's, but I do have my y and z already on this side. So that's already formatted. The last one to look at is my purple equation. I have my x and z over on the right-hand side. So again, just like I did with this green one, I need to get them moved over to the other side. And I'm just going to work that up here. Y is equal to negative 2x minus 5z plus 8. So again, my problem is these two variables are on the right-hand side, and I need them on the left-hand side. So to move that around, negative 2x, I need to add to move it. I'm subtracting 5z, so I need to add to move it. So I'm going to add it to both sides. And that gives me, my y was positive, so plus sign there. And I have 2x. Now, I want these in alphabetical order. So y would come next. Y was positive, so plus y plus 5z next. And then what was left with on the other side is just that 8. So 8. So I now have my 3 equations. And I am going to start putting this in the calculator. So go ahead and get your calculator out. You're going to start by typing in RREF, standing for reduced row echelon form. And then open your parenthesis. Don't worry about closing it yet because we're going to put something in there. And just like we pulled up the matrices yesterday, go to that middle section where it looks like a 3x3. Open it up. And remember, that was right next to the 9 is where we found that menu that pulled that up. But this time, instead of like we did yesterday, we are actually going to put it as a 3 rows and 4 columns. Because we need also that answer column in with what we're working with. So, when we're labeling these columns, we end up with your X column, your Y column, your Z column, and then your answers. We only have to do one matrix with this method. It's just going to be a 3-rowed by 4 columned. And you're going to go in and fill in your -3. Your next problem didn't have an X, that would be a 0 and a 2. And so forth, to where it looks like this. Once you have your matrix filled in, just press enter. And here is our goal. So remember that first column stood for X, next column stood for Y, and the last column for Z, next column for Z, then your answers. So in this first row, what I'm saying is X equals -6. On the next row, Y equals 15/8. And the last one, Z equals 29/8. And that gives me the ordered triplet of -6, 15/8, 29/8. And that's my answer. So when we were doing the matricing method or Kramer's rule, we would come up with problems where we couldn't answer. We would just say there's multiple answers. It could be infinitely many or no solution, but there was no way for us to determine using those which one it is. We just knew it had to be one of the two. With reduced row echelon, we can actually determine which one it is. And so let's look at this problem 2. And in this problem 2, we're going to again create that matrix that has the 3 rows and the 4 columns. And just if you can't remember how you get those typed in, we're going to be doing reduced row echelon. So you're going to do RREF, open your parenthesis, then go to the number the spot right beside the 9, and go to the center spot. Tell it you want 3 rows and 4 columns. And then we're going to start typing in the numbers we have here. 3, 5, -2. So our matrix, and I realized I left that step off. We had 3. So here it is. And from there, after we type it all in, remember, this right here is your X, Y, Z, and then answers. Press enter, and that's going to give you this. And the big thing to look at whenever you get this is notice how in the bottom row, there's no longer a 1. That means what that literally will translate to is 0x plus 0y plus 0z equals 0. That is always true. This is a infinitely many solutions. So our answer is infinitely many. Question 3, we're going to go through the same process. We're going to take in put it in row echelon form, trying to get it into row echelon form. So we're going to create a matrix that is 3-rowed by 4-columned. And again, we're going to type in reduced row echelon form. Then go to that center square. Tell it we want the matrix that's 3 rows, 4 columns. Then we're going to fill in and you're going to fill in on this third one by typing in the first column all your x's. So in this case, -5, -3, -6. When you get it typed in, it will end up looking like this. First column, -5, -3, -6. And the next one, -1, 0, 3, 3, 1, 2, -2, and 10, -6, 30. And press enter. When you press enter, you end up with your matrix C results like this. And so what that means, let's again focus in on that last row, because that's our telling row. That means let's know something. And you have 0x plus 0y plus 0z equals 1. So all this means is 0. Because if I have 0 of everything, that means I have 0. 0 cannot equal 1, so this is no solution. So again, if your last row has all zeros and a number, it's no solution. If instead it's just all zeros, it's infinitely many. Or if you have 2 zeros, a 1, and then a number, then it's going to be where you have an ordered triplet.